Glass, the product of the molten mixture of sand, soda ash, and limestone. A material used to make windows, bottles, and glasses. Glass fibers, the products of a similar molten mixture, yet with characteristics quite different from ordinary glass. Instead of being rigid, brittle, and fragile, glass fibers are soft, pliable, yet amazingly strong. Glass fibers resist burning, corrosion, will not conduct electricity, and can be combined with a wide variety of other materials. Unique properties that help make fiberglass the new basic material. In this program, we'll look at the special properties that make fiberglass unique and how these properties are used. Actually, glass fibers have been around for thousands of years, but the large-scale use of fiberglass began in the 1930s when a new company was formed to research and develop marketable uses for fiberglass. The company was called Owens-Corning Fiberglass. Today, the search for new commercial uses for fiberglass goes on here at the Owens-Corning Technical Center in Granville, Ohio. Since the 1930s, researchers have worked to develop those unique properties of fibrous glass into tens of thousands of commercial uses, like the familiar pink fiberglass building insulation. Fiberglass insulation works by forming the fibers into packs with millions of tiny air pockets. These pockets trap air and reduce the flow of heat through walls, ceilings, or floors. These same pockets also reduce the transmission of sound, making fiberglass an excellent acoustical insulation. One of the unique properties of glass fibers, resilience, allows the insulation to be tightly compressed for ease of transportation and economy in handling. Unpackaged, it springs back to its original shape and retains this shape through season after season of changing heat, humidity, and cold. Fiberglass insulation can be permanently compressed or formed into a variety of shapes, such as acoustical ceiling panels and heating and cooling ducts, which not only insulate against temperature loss, but acoustically dampen the sounds generated by heating equipment. The unique properties of glass fibers are among the reasons for the rapid growth of fiberglass as a reinforcement material. A glass rod, when weighted, fails. The same is true of a plastic rod. But reinforced with fiberglass, the plastic rod flexes when weighted, then snaps back to its original shape. This strength and dimensional stability combine to give fiberglass reinforced plastic parts, like this auto bumper, its ability to absorb impact without damage or distortion. From the beginning, Owens-Corning scientists saw the advantages of adding the unique properties of fiberglass to other materials. The challenge was to develop the technology to make the combination work. For instance, in the 1930s, Owens-Corning scientists patented the idea of reinforcing rubber with fiberglass. They theorized that the high strength, flexibility, heat resistance, and dimensional stability of the glass fiber would produce a tire that was tough, long-wearing, and smooth riding. It wasn't until 1963, however, when scientists perfected the means of impregnating the fiber with rubber to give it durability, that the idea became practical, and the glass belted tire a reality. Fiberglass, an inorganic product of an extremely high temperature reaction, is highly resistant to the deteriorating elements of the environment. Fiberglass resists burning and disintegration. This makes fiberglass textiles the ideal material for applications where fire safety is important. The inorganic makeup of glass fibers also means fiberglass resists chemical attack. A piece of copper dropped in acid immediately begins to disintegrate, while a piece of fiberglass textile material in the same acid is unharmed. This is why fiberglass reinforced plastic pipes and tanks are used for the transportation and storage of corrosive liquids, and why fiberglass materials are used as a filtration medium. Corrosion resistance, durability, and the inherent high-strength properties of fiberglass are the reasons behind the popularity of fiberglass reinforced plastic boats. In recent years, a specially developed alkali-resistant glass fiber has been used to reinforce Portland cement. Fiberglass reinforced concrete means a strong yet lightweight product because less concrete is needed to achieve comparable strength. When less concrete is used, less manpower and heavy equipment is needed to install concrete products. This application made possible products like these building exterior panels, weighing much less than the conventional concrete panel. Not content with designing new uses for glass fibers, Owens-Corning scientists have actually altered the properties of the fiber. Glass fibers in their basic form will not conduct electricity. This is easily demonstrated with the use of a voltmeter, a device for measuring the flow of electricity. When the electrodes of the voltmeter are touched to these metal tongs, the needle jumps, showing the passage of electric current. When the electrodes are touched to this piece of fiberglass reinforced plastic, there's no reaction. The non-conductive property of glass fibers is why fiberglass reinforced plastic is used for appliances and electrical equipment and integrated circuit boards. However, Granville researchers discovered a way to coat the fibers to make them conduct electricity. For applications like high-voltage cabling for car ignition systems. Conventional cable materials in the high-temperature environment under the hood become brittle and unreliable. Because of the inherent properties of glass fibers, high strength, elasticity, and resistance to high temperatures, fiberglass cabling remains soft and flexible. And still the search goes on. Owens-Corning people working a material with unique properties into combinations with other materials, as a replacement for other materials, revising old products into new, then altering the characteristics of the material to meet new needs. Fiberglass, the new basic material. Owens-Corning has developed new products and systems that add to the applications, broaden the market, or build on the company's technological expertise. The commercial success of these specialized products and systems, and for all fiberglass products, is due in large part to a marketing strategy developed at the time of the company's founding and to the people who made it a reality. That strategy? Pinpoint a market need, develop a fiberglass product or system to fill that need, then demonstrate its feasibility. Prove that it can be done with fiberglass. In this program, we'll look at some of these special fiberglass products and systems. Owens-Corning saw an opportunity to fill a demand in the underground storage tank market. Traditionally, storage tanks for petroleum products have been made of steel. Besides being heavy, steel tanks need coating or cathodic protection in some corrosive ground conditions. To prove it can be done with fiberglass, Owens-Corning began manufacturing and marketing storage tanks made of fiberglass reinforced plastic. Lightweight, strong, and environmentally safer because they're corrosion resistant. Today, fiberglass underground and above-ground storage tanks are in place in thousands of locations throughout the world. Another market need, an alternative for steel or concrete large-diameter pipe, provided further market development opportunities for Owens-Corning. Steel corrodes. Concrete pipes are heavy and difficult to install. Fiberglass reinforced plastic pipe retains the high-strength characteristics of steel and concrete without the limitations of corrosion and weight. Today, this proven technology fills an important need, and the markets for fiberglass reinforced pipe and tanks are well established. Meanwhile, researchers were pursuing another challenge. Could time-consuming manual production methods be replaced with higher volume production methods and processes for fiberglass reinforced plastic? The company combined this with a market need for an attractive, lightweight tub shower unit that wouldn't require time-consuming installation. Owens-Corning marketing and research personnel designed a multiple-piece tub shower unit that would capitalize on the limitations of conventional bath systems. Multiple pieces would allow the unit to fit through existing door openings. Wall panels would eliminate the need for expensive tile on the walls. Fiberglass reinforced plastic would mean that soap dishes and ledges could be molded in. Using fiberglass plastic molding compound in sheet form, giant presses, and compression molding technology, Owens-Corning produces a finished bath component in minutes with molded-in texture, structural ribs, and color. The company manufactures a variety of bath components, including tub shower units, mobile home tubs, and a series of components specially designed for installation in hotels and apartment complexes. In the early 1950s, the company added high-temperature calcium silicate insulation, KALO, to its traditional fiberglass insulations. Looking to broaden the company's insulation product line to include insulations for low temperatures, Owens-Corning began intensive work with urethane foam in the mid-1960s. Researchers found that combining the strength and design flexibility of fiberglass insulation with urethane produced an excellent roof insulation. Urethane could also be shaped into pipe insulation and covered with fiberglass reinforced plastic to add surface strength. This technology provided Owens-Corning with an opportunity to demonstrate urethane's effectiveness as a cryogenic or low-temperature insulation. The company won the contract to provide and install the insulation system for the Cove Point, Maryland liquefied natural gas receiving terminal. Here, LNG is brought to shore from tankers at -260 degrees by a pipeline insulated with a specially designed urethane foam with a fiberglass plastic outer layer. Owens-Corning's leadership in the development of fiberglass applications, combined with the company's technological expertise, helped to fulfill another market need which developed in the mid-1970s. The biggest insulation job in history, the Trans-Alaska Pipeline. In June of 1974, the Alyeska Pipeline Service Company awarded Owens-Corning the contract to design an insulation system for 420 miles of 48-inch pipe, the entire above-ground portion of the pipeline. The challenge, maintain the oil temperatures at 140 degrees inside the pipeline, while exterior temperatures varied from 70 degrees above to 70 degrees below. And design an insulation system that could be installed in temperatures as low as 30 degrees below zero. Owens-Corning scientists built an 80-foot section of the pipeline in an environmental control chamber at the company's technical center in Granville, Ohio. Here, the components of the insulation system could be subjected to the same wind, rain, and snow conditions the pipeline would face in Alaska. The final design for the insulation system consisted of straight panels of heavy-density glass fiberboard bonded to a galvanized steel outer jacket. Insulation at the anchor and support points was polyurethane foam covered with fiberglass reinforced plastic. In addition to designing and providing the insulating materials for the pipeline, Owens-Corning designed the heavy equipment needed to install the insulation material on the pipeline. Today, despite the ravaging forces of the brutal Arctic environment, oil flows from the North Slope 800 miles south to the port of Valdez, protected by an Owens-Corning designed, developed, and produced insulation system. In the years since its founding, Owens-Corning has developed technological expertise in a broad range of product areas. In fiberglass reinforcements, thermal and acoustical insulations, in fiberglass fabric structures, which open up a new world of design possibilities for sports complexes, schools, and shopping centers. In designing and installing the complete interior systems of office buildings. In higher volume manufacturing of fiberglass reinforced plastic materials. From fiberglass bath components to the insulation systems for the Alaskan pipeline, Owens-Corning people are making a material with unique properties fulfill the special needs of today and tomorrow, showing it can be done with fiberglass. Fiberglass, simply glass in fiber form, either spun into thermal or acoustical insulations, or pulled and gathered into strands for textile or reinforcement applications. Billions of pounds produced every year, distributed worldwide. In this program, we'll discover what happens when fiberglass products leave our plants, how our customers use it, and in what kind of products. Thermal insulation for buildings is the largest use of fiberglass wool. Long, thick blankets of the material are installed in walls, floors, and ceilings.
Before fiberglass building insulation is ever installed in a home or building, it could go through several intermediate steps. First of all, we might send it to an Owens-Corning supply center. Secondly, we could send it to a wholesaler who would then distribute it to a lumber yard or a contractor. And lastly, we might ship it to the warehouse of a retail chain who would then sell it to a do-it-yourselfer.
While Owens-Corning doesn't sell directly to the consumer, the company provides extensive promotion and advertising support to ensure that the consumer asks for our product. It's the salesperson's job to ensure that there are enough outlets handling our products and enough builders using Owens-Corning materials. Fiberglass insulation goes through a number of distribution steps before installation. In the case of manufactured housing, Owens-Corning sells directly to the producer.
In the manufactured housing market, fiberglass insulation is shipped directly from our factory to the manufacturer's plant. They install it much like a conventional builder, using fiberglass bats and rolls in the sidewalls, in the attic, and in the floors.
While most of the insulation produced is sold to residential construction markets, rising energy costs are stimulating an increased interest on the part of commercial and industrial building owners and operators. Owens-Corning salespeople work closely with architects and engineers to ensure that fiberglass materials are specified in the construction of commercial and industrial buildings, such as shopping centers and factories. Here, there's an opportunity to sell a variety of Owens-Corning products.
Commercial wall insulation, energy-saving ceiling panels, and built-up roofing systems all work together to keep energy costs down in a building like this. Our interior systems provide cost savings flexibility through movable sound screens, acoustical wall panels, as well as energy conservation through the use of fiberglass duct insulation and ceiling panels. Kalo, our high-temperature insulation, is used and specified on hot water and steam lines throughout the building.
Through the years, Owens-Corning has built up significant product and technical expertise, which is enabling the company to expand the applications for its products. Contracting division personnel sell both this expertise and fiberglass products, an important competitive advantage in working with large commercial and industrial customers.
Owens-Corning not only produces a full line of insulation products for power and process applications such as nuclear generating stations, refineries, and cryogenic plants, but also designs and installs these systems.
Owens-Corning also supplies insulating materials for specialized applications.
Fiberglass insulation serves a dual function in the appliance and transportation markets. Fiberglass insulation not only provides insulating value for refrigerators, ranges, and water heaters, cars, trucks, and trailers, but it also provides a sound barrier from motor and engine noises.
Fiberglass insulation, a fluffy blanket-like material sold to residential, industrial, and commercial markets to trap heat and sound. Fiberglass in filament form constitutes the other major segment of Owens-Corning's business.
Fiberglass reinforcements in textile materials are sold to the customer wound on a spool-like thread, chopped into short pieces in a loose weave, and with a variety of coatings and sizings depending on the end use.
Fiberglass yarns are sold to the weaving industry and are woven into such products as drapery materials, insect screening, and filtration materials. Other applications are reinforcements for paper and tape, where the high strength of fiberglass make these products shear and tear resistant.
Apollo astronauts wore spacesuits of fabric woven from fiberglass. Fire safety, shrink and stretch resistance, and easy care make fiberglass fabric popular for draperies and major industrial applications, such as structures domed with fiberglass fabric. Because of its light weight, durability, and strength, fiberglass is an excellent reinforcement for other materials, such as plastic, rubber, and even concrete.
The most widely known use of fiberglass is in combination with plastic resins. Owens-Corning sells these reinforcements and plastic resins to chemical compounders or molders.
These chemical compounders or molders mix the fiberglass resins to form molding compounds. Using a variety of molding techniques, they form fiberglass reinforced plastic parts, such as automotive parts, furniture, pipe, bath components, and boats. Rubber is another material commonly reinforced with fiberglass.
We sell special rubber-impregnated yarns to tire manufacturers to be woven into cords for fiberglass radial tires.
Belts of fiberglass in tires reduce tread squirm and heat buildup, thereby improving performance and increasing tire life.
A new application for fiberglass is as a reinforcement to be used in combination with concrete. Fiberglass reinforcement means that less concrete is needed to reach desired strengths. Therefore, fiberglass reinforced concrete parts are lighter and easier to put into place.
Marketing fiberglass products and materials requires people with special skills, special understanding of all facets of our customers' business, and the ability to convert a challenge into an opportunity. Exports to customers outside the United States constitute a growing market for Owens-Corning products. Exports build a base for our products in an overseas country. This means more jobs at home and may eventually lead to the establishment of a new overseas manufacturing operation.
We export most of Owens-Corning's product line. We ship basic insulating materials to Europe, reinforcements and yarns to Latin America, and specialty items such as tanks and pipes to the Middle East.
Glass in fiber form with unique characteristics that add a new dimension of usefulness. Fiberglass. Where does it go? Billions of pounds a year are produced and sold by the men and women of Owens-Corning into hundreds of markets for use in thousands of applications by hundreds of thousands of customers. Fibers of glass, formed by melting sand, soda ash, and limestone at 2,500 degrees, then flowing the molten mixture through holes finer than a human hair to form fiberglass, the new basic material. Fiberglass is strong, durable, corrosion resistant, yet it can be woven into fabrics softer than silk. Glass fibers will not burn, conduct electricity, or absorb moisture. They won't stretch, shrink, or decay. Bend them, twist them, and they'll return to their original shape. Glass fibers were first produced commercially in a small laboratory in the Owens, Illinois bottle plant in Newark, Ohio during the 1930s. Researchers were trying to find new products to make with glass and began to exchange technology with scientists doing similar work at Corning Glass Works. When the future of glass fibers became apparent, they formed a separate company to develop commercial uses for the new material. The new company was called Owens-Corning Fiberglass. Today, Owens-Corning Fiberglass is a Fortune 500 manufacturing company with annual sales of over $1 billion. More than 22,000 employees, with manufacturing facilities, sales offices, and distribution centers across the United States, and wholly owned and joint venture manufacturing locations around the world. Owens-Corning's glass fiber materials are made in two basic forms. In one manufacturing process, the fibers are spun by high-pressure air into fluffy packs. This is the process used to make Owens-Corning's oldest and best-known product, pink fiberglass building insulation. Fiberglass insulates by trapping air in the thousands of chambers formed by the glass fibers, thus reducing the flow of heat or cold through walls, ceilings, or floors. But building insulation is only one of many thermal and acoustical insulation products. Roof insulation, pipe insulation, and air handling systems are made by compressing or forming glass fibers into desired shapes. A special facing material turns insulation panels into attractive fiberglass ceiling panels. To broaden its line of insulation materials, in 1958, Owens-Corning acquired the rights to manufacture a calcium silicate insulation called Kalo for high-temperature applications. And in 1970, a manufacturing facility for urethane foam insulation materials, an effective low-temperature insulation. In 1977, Owens-Corning acquired a manufacturer of roofing and asphalt materials. These products complement Owens-Corning's roofing products, such as insulation and built-up roofing systems, enabling the company to offer a complete line of roofing materials. Owens-Corning also has developed significant systems engineering expertise in its various product areas. At the Cove Point, Maryland liquefied natural gas receiving terminal, an Owens-Corning engineered insulation system keeps the liquefied natural gas at minus 260 degrees as it's moved from the receiving docks offshore to the storage facilities onshore. Owens-Corning not only provided the fiberglass reinforced urethane pipe insulation, but designed and installed the system as well. The Trans-Alaska Pipeline was the largest insulation job in history, and Owens-Corning designed and built the system to insulate and protect the above-ground portions of the pipeline. To keep the oil inside at 140 degrees for 420 miles, despite outside temperatures ranging from 70 above to 70 below. A specially designed installation system lifted the flat insulation sections in place over the pipeline, then crimped and held them in their final shape for attachment. Another component, a fiberglass reinforced plastic, insulates and protects the pipeline support system. We've used our knowledge to design and install insulation systems for energy-generating plants and refineries. In these jobs, huge energy-carrying pipes, turbines, boilers, and tanks must all be kept within a specific temperature range. In major construction jobs like the new headquarters building of Ohio Edison in Akron, Owens-Corning designed, provided product, and installed the entire interior system of the building. This included the air delivery system, lights, acoustical ceiling panels, and a complete open office system. The open office system combines fiberglass sound screens, wall panels, and a sound masking system. The result is lowered initial cost, maximum flexibility, and modern appearance to meet the changing physical requirements within the office. The company's other major manufacturing process produces a textile strand or yarn, which can be woven into fabric or used to reinforce other materials. Glass fiber fabrics are used as draperies in homes and offices, and as special fabrics able to withstand higher temperatures than fabrics made with synthetic or organic fibers. Teflon-coated fiberglass fabrics supported by air pressure or cable systems are a new cost-saving roof system for sports stadiums, community centers, and recreation complexes, while providing unusual and aesthetically pleasing appearance. When combined with other materials, glass fibers provide greater strength and stability to the material, they act as a reinforcement. Automakers use fiberglass reinforced plastic in increasing numbers of applications. Easily molded, one-piece fiberglass reinforced plastic parts eliminate the need for numerous sub-assemblies and welding operations. Because fiberglass reinforced plastic parts are lighter than steel, overall car weight can be reduced, making improved fuel economy possible. Fiberglass reinforced plastic boats have replaced wood as the standard of the pleasure marine industry. The inherent corrosion resistance, high strength, and molded-in color of fiberglass reinforced plastic makes them almost maintenance-free. Fiberglass reinforced plastic bath components have become a popular alternative to traditional porcelain-covered cast iron or steel products. Owens-Corning's research into polyester resin technology as a means of furthering acceptance of fiberglass reinforced plastic has made the company one of the world's leading producers of polyester resins. But plastic is not the only material to receive the benefits of fiberglass reinforcement. Fiberglass belted tires give a smooth ride, are long-lasting and tough. Fiberglass belted radial tires are standard equipment on many new American cars and have gained rapid acceptance in the replacement market. Through its two basic manufacturing processes, Owens-Corning provides a full line of fiberglass textile, reinforcement, and insulation products. What about the future? To continue the company's pioneering efforts in product and systems, Owens-Corning invests heavily in research, development, and engineering. With a staff of over 800 scientists, engineers, and support personnel, the Owens-Corning Technical Center in Granville, Ohio, is one of the world's finest research facilities. The Technical Center includes both organic and inorganic chemistry laboratories, product testing laboratories, experimental facilities for forming textile glass fibers, and areas for analyzing, testing, and improving the equipment used to manufacture fiberglass product. Owens-Corning looks to the future internationally, with wholly owned subsidiaries and affiliate companies manufacturing fiberglass products around the world. Today, industry's challenge is to conserve energy, improve productivity, and hold the line against rising costs. Tomorrow, new problems will surely arise. Problems that can be solved through the use of glass fibers and by the people of Owens-Corning Fiberglass.